In this video, we're being asked to solve tangent of 2x equals to radical 3, for x being between 0 and 2 pi. You'll notice here that 0 is included, but 2 pi is not. So, our first step is to determine, again, is the value that we're looking at going to be something that we're looking at in the unit circle. And tangent of theta, and that's the way I'm going to look at it in the first case, is tangent of theta equals to radical 3, is a value on the unit circle. It's a value on the unit circle such that I recall that it's going to be radical 3 over 2 divided by 1 over 2. This setup here gives me a value such that I'm looking at either sine of theta divided by a cosine of theta, and I just have to figure out at what theta measure this could be satisfied. You'll also note that I could also potentially use a negative radical 3 over 2 divided by a negative 1 over 2. This will also be a positive radical 3. Now again, this seems like I'm pulling this out of nowhere, but in reality what I'm truly doing is looking at the unit circle, and I'm going to go ahead and take all my sine values, 1/2, and I will divide them by their cosine values at that location. And 1/2 over radical 3 over 2 will not simplify to be a radical 3. It will simplify to be a radical 3 over 3. If I attempt to take this one here, where I take radical 3 over 2 and divide it by 1/2, I end up with this, which gives me radical 3 when simplified. So it should make note that pi over 3 is a value that will satisfy the tangent of theta equaling to radical 3. So I'm going to make note of that my theta measure could be equal to pi over 3. What other location on the unit circle could satisfy this equation? Well, over here we're going to have positive over negative. Down here we're going to have negative over positive. But over here we will find a location at 4 pi over 3 where a negative radical 3 over 2 divides by a negative 1/2 and provides us with, once again, radical 3 for tangent. So at pi over 3 is one solution, at 4 pi over 3 is the other. However, this is in terms of theta. Now notice again what I did here is I, for a moment, ignored the 2x and said I was looking for an angle measure inside of tangent that's going to give me radical 3. Those two angle measures inside of tangent are pi over 3 and 4 pi over 3. This will provide me with the concept that tangent of 2x such that 2x is equal to pi over 3 will give me my solution. So 2x must be equal to pi over 3, or 2x must be equal to 4 pi over 3. In this case, I'll divide both sides by 2 and provide myself with pi over 6 as a potential solution for x. This one, I will end up with x equals 2 pi over 3 as a potential solution. Now, there is a slight issue with the way that this is going to be solved. The concept that I'd like you to think is that tangent of 2x, that this function is actually going twice as fast. So even though when you're looking at this, and I'm going to find a solution here and here, it's actually only finding solutions up in these two first quadrants in some form or other. Again, you'll notice where pi over 6 sits and 2 pi over 3 are here and here. With it only happening here and here, I would like to argue that there's probably values down here that will work for 2x that wouldn't have worked for theta. Now the easiest way to find these values is to say, well, let's just go ahead and continue to revolve using theta. So at pi over 3 this will work. If I were to add 2 pi to pi over 3, again doing a common denominator, 2 pi is the same thing as 6 pi over 3. And if I add that to pi over 3, it gives me 7 pi over 3. This is another value that would work on this function here. Now it won't work again for x between 0 and 2 pi, assuming that x would have been theta. But again, theta is 2x. So I would argue that this value should also work. The same thing can be done with this one, where I end up having 10 pi over 3. With these two new values, if I were to set them each equal to 2x and test them inside the equation, I'll divide both sides by 2, giving me 7 pi over 6. And you'll note that 7 pi over 6 is actually a value between 0 and 2 pi. So it will satisfy this equation of tangent of 2 times x equals to radical 3, such that my x value is between 0 and 2 pi. My last one is going to be 2x equals to 10 pi over 3. And when I solve that one, I end up with, again, 5 pi over 3. Giving me 4 potential solutions. Now the concept is that when I'm solving tangent of theta, there are only 2 solutions on the unit circle. Now there could be one, there could be none, but there are 2 clear cases on this function in that range. But since I'm using 2x, there should at least be twice as many solutions. If this was 3x, it's possible that there should be 3 times as many solutions. So if I found 2 solutions here that satisfy theta, there might be 6 solutions that actually satisfy the 3x that would have been there. So in this case, between 0 and 2 pi, those 4 values all satisfy this equation. And again, what we should do to ensure this is plug them in. Tangent of 2 pi over 6, is that equal to radical 3? Well, that's the same thing as tangent of pi over 3. So that is equal to radical 3, and it will check, as well as all 3 of the other remaining solutions. They do all check, and those are the 4 solutions to this equation. Tangent of 2x equals to radical 3.